Welcome back to some notes, everyone. Lesson 5.5. This is going to deal with proving triangles are congruent, and we're going to learn two new shortcuts. So, a couple lessons ago, we learned about side angle side, so some SAS, S-A-S. So we've already learned about side angle side, and we're going to learn two more today. But first of all, some vocab: legs and hypotenuse. We learned about legs and isosceles triangle are the two sides that are congruent, right? And then it had a base. But if we have what's called a right triangle, so a right triangle, the side opposite the right angle is the hypotenuse, and the other two sides are the legs. You're going to need to know those. So we have some common vocab to help us with one of our theorems today. So let's look at this first theorem called the side-side-side theorem, SSS. This just says if three sides of one triangle are congruent to three sides of the other triangle, then the two triangles are congruent. Easy. Then we have the hypotenuse leg theorem, known as the HL theorem. This is because we do not have a angle side-side or side-side angle theorem. We don't. Um, the closest thing we have is called the HL theorem. Now, there's something that's important about this. If I read the if statement, it says if the hypotenuse and the leg of a right triangle are congruent. So here's the thing. To use the HL theorem, you must prove or show three things. To use it, you have to start off with, you have to show that you have a right triangle. You have to show that the hypotenuse and a leg are congruent to the hypotenuse and a leg of the other triangle. You have to be able to show all three of those before you can even state you have the HL theorem. So let's get going with this. Decide whether the congruence statement is true. Now, the tricky part here is the question. It says the congruent statement, not if the two triangles are congruent. So I'm going to look at the congruent statement, which means I need to look at the order. This says triangle ABC is congruent to EDC. So A to B to C, I'm going to start here and I'm going to go this way and then this way. And I'm going to look at the markings. I have, and then I'm going to look at the next one. So I'm going to start at E and I'm going to go to D and go to C. Let's check the markings here. I have one congruent mark, one congruent mark, three. One congruent mark, one congruent mark, three. So yes, there is enough information, and that's using the side similarity. Number two, first off, I'm going to put in a congruence mark here because of my reflexive property. And let's just check the statement now. KGH, K to G to H. And is that the same as H to J to K? So let's double check we have here. We are going from, and maybe I'll change the color here so that you see which way we're going. I go from two marks to one to three. So two, one, three. So here, two, one, three. They're in the same order. So yes. And then we see side. So we do see that, but we had to use our reflexive property to get there though. Okay. So it wasn't in the given. In a way, it wasn't. All right, let's look at number 3 and 4. I do like these quite a bit because they make you slow down. If I look at 3, it says UVW. So I'm going to start with U, go to V, go to W. So I'm going to start here. And I want to compare that to X to Y to Z. So if I'm going to see if the congruent statements are true, I'm going to look through this and let's see what we have. I go from 1 to 3 to 2. Here I go from 1 to 2 to 3. The order is incorrect. So the congruent statement is no. The congruent statement is not true based on the diagram. No, the triangles are congruent, but the congruent statement is what we're trying to determine if it's true or not. So that's a no. Number 4, let's just go ahead and quick check RST. So I'm going to go to R to S to T. So that's going this way, R to S to T. And then I want to check R to P to Q, R to P to Q. If I look here, I'm going 1, 2, 3, 1, 2, 3. So yes, and that's from the side theorem. All right, we're gonna skip number 5. We don't really talk about things being stable. Some schools do, but we're not going to do that. So we're going to skip number 5. And we're just going to do one proof. We are going to do number 6. All right, because number 7 is just a lot of tedious writing, and we could do 7. But I just want to focus on number 6 right now. It first says redraw the triangle so they're side by side with corresponding parts in the same position. All that means is could I draw both of these like this, corresponding parts in the same position. So I'm going to have A, C, B. There's my right angle. And then I'm going to have E, D, B. There's my right angle. And I'm also going to mark down that EB is congruent to AB. Now, I can already tell you that I have right triangles and I have hypotenuses that are the same. But the given doesn't say right triangle. The given is only that they're right angles. So we have to address that. And it does say B is the midpoint. Now, here's what I know about midpoint. Midpoint creates two congruent segments. So if B is the midpoint, that means in this specific diagram, I can mark CB and BD congruent. And when I do that in my proof, I'm going to have to say the reflexive property. So let's go ahead and write this proof here. So the first thing is we have our given. So B is midpoint of CD, AB is congruent to EB, and angle C and angle D are right angles. I'm shorthanding here for the sake of time, and this is all of our given. Now, the second thing is I might want to first, if I want to use the HL theorem, remember I have to show or prove that the triangles are right triangles. So what I can say is I can say triangle ABC and triangle EBD are right triangles. How? Because I see right angles from my given. That's the definition of right triangles. I'm abbreviating here. So there's one of my requirements. I have that. I also have that AB is congruent to EB, which is my hypotenuse. So the last thing I need is, before I do my proof, is number 3 is what we drew in there earlier. Because of the midpoint, I can say that CB is congruent to DB. CB is congruent to DB. And we did that because of definition of a midpoint. If I look at my diagram now, I can see that I have my hypotenuse, my leg, and my right triangle. So my last line of my proof is that triangle ABC is congruent to triangle EBD, and that is the hypotenuse leg theorem. All right. Sound good? I really hope so. All right, and I'm not going to do number 7, but you could reach out to me in person or ask me in class, and we could find time to go through that together if you would like. All right, let's take a time. We're not going to do that right now. So if you have any questions, feel free to reach out. If not, we will see you in class, or you'll just hear me in the next video. Have a great day.